another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're continuing on in VMware. That's right, the VMware Certified Professional version 6, and this is actually a part 2 in storage multipathing. Yeah, there's more than one path you can take, and before I set myself up with a bad Yoda joke, joining me in the studios is none other than Mr. Don Vazette. Don, how you doing, sir?
I'm doing swell, Wes. Ready to dive right back into part 2 of storage multipathing. In our last episode, we got a chance to see how to configure multipathing, just to get it turned on, right? And it took me apparently 30 minutes to do that. So we got it turned on. We saw we are multipathing, but we're multipathing in the default manner. And I want to start off this show by showing how to change that, right? So if you remember from the last episode, let's refresh our memories, that when you have more than one path between an ESXi host and its network attached storage, be it a fiber channel SAN or iSCSI or whatever, when you have more than one path, there's 3 modes we can connect with. There's fixed, where we have one defined connection that we always use unless it fails, and then we have a backup, right? That's the fixed method. There's MRU, or most recently used, and that's where whichever one was active first we use, and if it fails, we just flip over to another one, unless it fails, and then we flip back, right? Most recently used. And the third mode is round robin. Round robin is where we load balance our traffic across both paths. So now not only do we get redundancy, but we also get a performance boost. And we saw in the last episode when we turned on multipathing that it defaulted to fixed. That's the default. And now we want to get in there and change that, right? We want to modify that. Now, the multipathing is controlled by what's called a PSP, a path selection plugin. And the path selection plugin, well, there's one for each of the 3 modes. So we basically just have to tell the system, don't use this PSP, use this other PSP, and then it'll use the right one to get in there and get connected. And that's done at the data store level. That means we can have more than one data store using a different PSP. I might have one data store that's set to use fixed and another data store that's set to use round robin. It's at the data store level. It gives us a lot of flexibility. All right. So let's dive in and take a look at that. So I'm connected into my vCenter environment, and I'm looking at my data store. So I've got this ESX host 01 iSCSI data store, and I'm going up to Manage, Settings, and Connectivity and Multipathing. And when I look at my status for this connection, I can see that I've got 2 paths right now. And the 2 paths are both connecting me to LUN 0, so it's one hard drive, and I'm connected to both. And this one is showing as active I/O. We've defaulted to fixed. And in the fixed environment, all of our paths go active, but we're only sending disk I/O over one of them, the fixed one, the first one we defined. And I can see way over here in this preferred column, this one has an asterisk, right? That's the first one. That's the one that we define, and it's the one that's going to be used. If it were to fail, then we'd flip over to this other one, and we'd only return here if that link came back up. When the link comes back, we'll jump back over to it, and that's it, right? And if I look up here in my details, if I can scroll my screen right, there we go, you can see where my path selection policy right now is showing as fixed. All right, and if I expand that out, I can just see it's fixed, and here's my preferred path with that name that doesn't mean a whole lot to me. All right, so that's how I know that I'm running fixed. And right over here, we've got our edit button where we can jump in and change that behavior. And so if I edit that, now I'm going to come in and I'll see my paths, right? And see how it's showing this guy as my preferred right now, and then I'm in that fixed mode. And if I drop it down, now I can pick between most recently used, round robin, and fixed, right? And see how they all say VMware? VMware wrote all this using their VESA storage API, VASA, and that VESA storage API allows third parties to write their own plugins. So anybody out there can write their own plugin, we can inject it into vCenter, and then we would have that choice here. So they flag these as VMware so you know that they're the original ones that came with vCenter, that VMware supports. If you choose a third party one, that's fine, but VMware won't support you. You got to call the third party for support if there's a problem. And there are a few SAN vendors out there that have special plugins for communicating with their SAN because they have some crazy feature or benefit where they, usually it centers around reducing fault detection on round robin. Because round robin with VMware can take a little while to detect a fault. It can take a few seconds. Some third parties have gotten it down to where it's very, very fast, and it makes it a great solution. All right, well, if I choose MRU, I'm not really going to see anything change here because MRU uses whichever one was up first, which is whichever one I configured first for fixed. So for me, fixed and MRU are going to be about the same. I'm going to choose round robin. Round robin is different. With round robin, it's going to say, I don't really care which one came up first. If they're both active, let's go ahead and bring them both active. I'm going to round robin my data between the two so I can take advantage of both links. And then if one link goes down, I'll just shift all my traffic over to the one that's up. And when the second link comes back online, we just bring it back in, and now we're round robining again. It gives us that balance, and we're in place. All right. So I'm going to go ahead and choose that, and I'll just hit OK. And what we're going to see is after a moment, the PSP will change from fixed to round robin. And now the new behavior is going to take effect. Now, you probably want to do this after hours or when you can afford some downtime unless you've tested it ahead of time. Most of the time, your virtual machines have no idea the change occurred, and everything just runs smoothly without a blip in the world. But I have occasionally seen where a third-party storage controller driver can start to freak out a little bit when you make this change, and you end up having to reboot your host. A simple reboot takes care of it, but if you have to reboot the host, your VMs can start to get messed up. So what I recommend is either doing this after hours, or if you've got vMotion set up, just move your VMs to another host, configure multipathing here, and then move your VMs back to it after it's configured. And that way you don't have to worry about your guests getting locked up.
Now the ESXi host, they can see those paths. How about the SAN? Can the SAN see those paths, and if, or do we have to do some kind of configuration to make that happen?
So there's actually something interesting here. Your SAN, it sees the paths, but the SAN doesn't actually care about who connects. The SAN is going to see it as different people because it's tracking it based on your HBA identifiers, your worldwide names, and those things. So it thinks that it's two different people connecting. So ESX is really where the logic is happening here. It knows, hey, I'm doing round robin. It knows I've got two paths. I'm going to keep one active and one not active, and that's how it goes. So for the most part, this is entirely inside of ESXi. But there is an exception. All right. Your SAN, in addition to having multiple network adapters, your SAN might have multiple storage processors, right? HP is really big into this. When you buy an HP eSAN, they always have the option to get a second controller. And the controller, that's your processor and memory. It's the logic of the SAN. It's basically a server built into your SAN. Having redundant network adapters is nice. Having redundant hard drives is nice. But having redundant processors, now it's like having two SANs that just happen to be in the same metal box, right? You could have redundant power supplies, redundant processors, redundant hard drives, redundant network adapters, redundant HBAs. And now you really do. You have two SANs that just happen to be in the same metal box. You have a complete silo failure on one side, and the other side takes over, and it's fine and it's running. The only thing it doesn't protect you from is your facility crashing, right? So if you have that kind of environment set up, your SAN might have two network adapters where one adapter, or HBAs, one HBA runs into the processor that's active, and the other HBA runs into the processor that's not active. And if that processor is in standby, what is VMware going to see? What is ESXi going to see when it looks at that path? It's not going to see anything, is it? So there's actually a protocol that those systems can speak so they recognize what's going on. And what it's called is asymmetric logical unit access, right? And what it means is that I might have more than one path to the SAN, but on the SAN side, only one is active and the other one is standing by, okay? Not on the ESXi side. And on the SAN side, if its main processor fails, the other processor takes over and becomes active, and now we flip over to it. So it's just like fixed or MRU, but on the SAN side instead of here. So it's ALUA, asymmetric logical unit access. And VMware, ESXi, it's aware of that. It knows about ALUA. It knows how to read it and see what's going on. And so when it looks at that second path, it'll see the other controller, and it'll see that it's in standby. And it'll say, okay, all right, I got a path here, but it's in standby. So if I turn on round robining, I'm not going to round robin traffic to a processor that's in standby. There's no point. So even though round robining is on, I'll still only have that one path to the active processor, and that's it. So when you turn on round robining, we should actually see it here on mine because I'm pretty certain my controller is going to run this way. We'll find out here. Let me refresh it. It's still showing fixed, so I'm going to refresh. There we go. All right, so mine's showing round robin, and so it's up and going in theory. I had two paths, so if I look down here at my two paths, oh shoot, nope, both mine went active. I've only got one processor in my SAN, and so it's showing it as active both ways. It's both of them are now active I/O, right? I'm sending traffic across both links to get to that iSCSI SAN because they're both active. But if I had a second controller that was in standby, then it can't bring the other one active because the processor's in standby. And so it's actually going to change this status, and it'll say standby. There's actually 4 different statuses that we can see here, or 5. Active and active I/O, those are the ones you normally want to see. Okay? Active means, yes, I see the processor, I can jump onto it whenever I want. And active I/O means, yeah, I see the processor and I'm sending data across it, right? So in my case, both of mine are in that status. Those are the ones you want to see, all right? You might also see standby. If it says standby, that's ALUA. You can see a processor, but the processor on the other side is not active yet. And so only when it goes active will we flip over to it, okay? On the SAN side, they have a different terminology for it. So here we call it active and standby. But on the SAN side, they have what's called active optimized and active non-optimized. Okay, active optimized, that means it's an active path and the processor is running. Active non-optimized means it's an active path, but the processor's in standby and I shouldn't send traffic over it. It's non-optimized. All right. Unless the optimized path goes down, I'm not going to touch that non-optimized one. It's just going to sit there. Even if I turn on round robin, it's not going to use it. All right, so that's where the SAN gets involved. So, you know, Wes's original question was, do we have to do anything on the SAN, or does the SAN get involved? The answer is yes, if it's got more than one processor. In my lab, my SAN only has one processor. And so it's going to be active no matter what, and I see it across these 2 paths, and that's why I've gone active-active.
Don, do we get the ability to see these active links if one's active optimized versus if one's non-active, active non-optimized,
Yeah.
I should say?
Yeah, active non-optimized is easy to spot. It doesn't say it, it just says standby, right? So if it says standby, that's active non-optimized. But if it says active or active I/O, that's active optimized, right? So those both count. So that's what you're going to see. There are 2 other statuses that hopefully you don't see. There's disabled and dead. And so I guess disabled is not so bad. Disabled is where you have disabled a path, right? We can choose one of these paths and disable it. All I have to do is if I highlight the path, I got a nice big disable button. We can disable it, and that's going to flip it to disabled, right? And it'll take it a moment, but that'll refresh. Let me just manually refresh. And that'll flip over, and so now I'll have 2 paths, but one's disabled. And see how it says disabled I/O? It's disabled. We would be sending I/O on it if it was enabled. That's what that little note means, not that we're actually sending I/O on it, but it's now disabled. Okay, so that's one status you might see, and then I can always re-enable that one. The other one is dead. And dead, the triangle is empty, but it's got a red line around it, so it's red. And that's letting you know that it should be active, but we can't see the LUN, and we can't see the processor on the other side. Something has happened to that network, all right? And we've got a failure. Now, when you have a failure like this, VMware has some interesting terminology they use for failures. When it says dead, in theory, it's just the storage controller, right? But it could actually be more than just the storage controller. It could be the entire host. If that entire host is down, vCenter will still know about the data store. The data store is stored in vCenter's database, but it won't be able to talk to the data store because the host is down. All right. So when we have an outage in VMware land, the 2 terms they use are PDL and APD. PDL is permanent data loss, and APD is all paths down. Okay. Permanent data loss is what we normally see here. When we see one of these guys go to dead, it means that we've lost connectivity to the storage. The host is still up. The host is running, we can talk to the host, but it can't connect to the storage, all right? And that's called permanent data loss, or PDL. We have no way to recover that data because the link is down. Until that link comes back up, then we'll have access to our data store again, okay? So PDL is what you're normally gonna get. But if the entire host fails, yeah, the storage is down, but so is everything else about that host, and that's called all paths down, APD. All paths down doesn't just refer to the storage paths, because you can get all paths down without multipathing even turned on. It refers to the storage, the network, the data stores, the VMs, the host, like every single bit of it. If you power the host off, if you just walk up to it and yank its power cables out, that would be an all paths down, right? So APD and PDL, those are the 2 kind of statuses. You'll see them in the error logs.
Now, with setting these multi-paths, is there a way that we can perform any kind of monitoring on them? Like I was saying, if you can see these links, whether they're active optimized, but is there a general way that we can see monitoring?
For the most part, the monitoring is what we see right here, right? So when I go into the data store, I go into manage, settings, connectivity, and multipaths, that we can verify their status right here. So this is normally we're going to monitor that. As far as performance, though, if you're trying to monitor utilization, you've got your traditional monitoring. We monitor this storage just like we monitor any other storage. The data store has a certain amount of I/O. It's just being balanced across the links, and so we can monitor it that way. It's somewhat limited, though, when we come in here, because when I come in and start looking at performance, it's going to lay things out for me. Here, let me go real time, which is going to make my computer a little slow, but we'll do it anyway. Because I'll see like storage I/O. We saw this in the storage I/O control episode. So I can see my communications, but it's not breaking it up by the adapter, right? It's kind of total. So for this data store, here is the disk I/O I'm generating. If I'm in MRU or if I'm in fixed, then I know this is all traffic over one adapter. But if I'm round robin, I have to do a little aggregation in my head and say, okay, I've got two 4 gigabit links, so I've actually got 8 gigabit of throughput. Now let me put that in the context of these reports and interpret it from here. With round robin, you should have even traffic over each link, and it doesn't give us a great way to monitor and see that aside from these reports that are already aggregated. All right, so that pretty much tackles those. I think that's a pretty good rundown of multipathing. We've got a multipath solution in place now. I'm sending my traffic across 2 links. I'm increasing my bandwidth. If I have a failure, I just flip over to the other one. I can start throwing VMs in this data store, and they'll take advantage of multipathing. All right, now what I've shown you is probably all you need to know for the exam, but I do want to throw one thing out here for real life land, which is there are other things you can configure with multipathing. For example, LUN masking, right? I have 2 connections to the same iSCSI target. Let's say that I had 5 different LUNs on there, and I want some LUNs to use multipathing and some LUNs not to. Well, by default, I'll see all the LUNs, and so they're all available for multipathing. And it'll default to fixed, so I'm not too worried about it, but maybe I don't want that, right? So what you can do is you can configure LUN masking, where you go in and you tell the system, like, hey, on this path, hide these 2 LUNs. And on this other path, hide these 3 LUNs. Well, you don't have a way to do that in the UI. But you can drop down to the command line. You can do it through PowerCLI or through the regular command line tools that are a part of ESX, and you can configure things like LUN masking. I doubt it'll show up on the exam, but in real life land, if there's ever a time where you need something like that, just know that just because it's not in the UI doesn't mean you can't do it. You'll just have to drop to the command line. And I'll put a link in the show notes to some of the configuration documents on VMware's site, and they've got it all laid out. The commands are not easy. Nothing is in the command line, but the functionality is there for you to take advantage of.
All right, so a lot of great information here, Don. Does look like we're coming to the end of another episode here, but before we do you got any additional advice you would like to impart to us when it comes to multipathing?
The main thing is you'll want to monitor it, right? You'll want to keep an eye on it, make sure that it is working the way that you expect it. Test the failover. Just make sure that your systems respond. Remember, if you go round robin, absolutely test failover, because you just want to make sure that your software survives the failover. If your software does, it works great, and then you don't have to worry about it. If your software doesn't react well, then that's kind of your warning to say, yeah, let me move over to MRU, or let me move over to fixed, and round robin would be nice, but it's just not going to work out for me. And also remember, different data stores can have different plans, or PSPs. So I can go to one data store and set it up for round robin, and go to another data store and set it for fixed. And if I have some software application that just doesn't play nice with round robin's failure detection, I can move it over to the fixed data store. And then I can have my stuff that does play nice over in the round robin one. So you can mix and match and really take advantage of this. It's all there for you to use. It's just got to get set up.
All right, Don. Well, thank you for giving us all that great information, and thank you to the viewer for watching. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.